Hi, today we will be testing. I will be demonstrating a swimming pool with a dimension of 10 meters by 20 meters and 100 meters deep. We will be testing. Um, we will be testing regarding the pressure. How much does a person will how much will a person receive pressure when he is swimming at the depth of 100 meters? I will be using Solidworks Flow Simulation, and here is the project. I will now open Solidworks. As you can see in the design tree, I have this swimming pool. This is the swimming pool, and there's the person. You see, the person is there. He's 5 feet, and the dimension is 10 meters by 20 meters and 100 meters deep. And there's also a cover. You know what? As how SolidWorks work, there should be it should be airtight for this kind of like example, if you're also uh, working with hydrostatic or you're testing for hydrostatic pressure, then you need to work in with uh, airtight airtight system, like everything is covered. And then later I will show you. And then there's a cover, and then I remove, you see. And I also make a center line here. From here, from the bottom to the top, I put a center line sketch so that I can place a reference for this coordinate system. I mean for my coordinate system. I mean, so as you see, this is how the swimming pool is deep. You see, it's 100 meters. And now, actually, I already made a flow simulation project. This is the project, and as you can see, I will open general settings. This is an internal, and you need to check this heat conduction in solids if you are working with water alone, if you're not using a multi-phase, or if you're not using an admixture or two gases or two elements or substance in this in one study, then you need to enable the heat conductions for this to run. And also use the gravity as always on the negative y direction and with 81 meter. And make sure that do not check this, make it an internal, because we will need the cavities. We will need the cavity. You see the cavity in here. We will need to compute here the cavity. And in my fluids, I only used water from the liquids. You see, only use water. It's already here. That's why. And and then the solid, I used concrete, cast concrete. And in the wall conditions is adiabatic wall. My initial condition. And this one, you really need to pay attention for this. For this one, actually at the sea level, or I mean in the water level, mostly it is 180 m, or it should be 101,325 pascals. Most probably it is assumed that at water level it is at 180 m, the standard atmospheric pressure. And now, as you see, this is you need to check this this refer to origin. You really need to check this one, because we will be testing here. You know, if you are using like the water testing for hydrostatic pressure, you need to make sure that the coordinate system should be at the top level of the starting. I mean, it should be in the top of the water where it starts at the level of the water. So I also change my coordinate system to my system. You see, my coordinate system, and I use the y-axis as a reference since we are testing for the y-axis, and that's it. And this is this study is a static study. This is not a transient study. And as you can see, if I will show the pressure, you see the pressure is very high. Imagine a person, see, is experiencing a very high pressure. If I will enable, you see, if I will show the plot maximum, then the plot maximum would be very high. It will be 1,075,471.20 pascals, or it is like 155.98 psi. It will be extreme. And Even the car tire is at 30 to 35 psi. And even this is intense because the pressure is too high. Mostly for scuba on air, there is a limit of 40 meters. It is advised. And if you reach at the 100 meters, it can be deadly because of the risk of nitrogen narcosis, because the air or the oxygen is very low as you go deep. So as you see, this is how it would be. This is how the person will experience pressure at this level. You see, it's not advisable. It's like 155.98 psi. And that's it for this study. And thank you for watching. Bye bye.